students, I'm Mr. Pei. Welcome to my channel. Before our discussion today, please give me some encouragement. Subscribe my channel, like and share my video so that more students can learn and get benefits from my teaching video. In today's video, I'm going to discuss with you another example of KSSM Physics Paper 3 question. The question I'm going to discuss with you is regarding the experiment in Form 4, Chapter 6, Line Optics, Section 6.1 Refraction. Aim of the experiment is to determine the refractive index of the glass block. And this experiment is actually one of the compulsory experiments in Form 4 syllabus. The experiment is Experiment 6.1 in Form 4 textbook, page 236. You may look at the aim of the experiment to determine the refractive index of the glass block. In the diagram, you may see that the apparatus used is red box together with rectangular glass block. And the question asks you to determine the refractive index of glass block. So where you need to identify the reading of I and R. The manipulated variable for the experiment will be angle of incidence, and the responding variable for the experiment will be refractive index. In this experiment, the incident ray will be directed from less than medium to denser medium, so that your I will be greater than your R. This is because the light speed in the air is faster compared to the light speed in the glass block. Let's see what is the summary of the experiment 6.1 you have already did together with your school teacher. Basically, you was learn to draw the graph sin I against sin R, and you will get a graph with straight line pass through origin, and the graph will be used to determine the refractive index of the glass block with the formula of sin I over sin R, so that we know that the gradients of this graph represented as the refractive index of the glass block. Here is the extent knowledge for the experiment 6.1, where the refractive index you find can actually use to find out the speed of the light in the glass block with this formula. And we know that the speed of the light in vacuum or in the air is equal to 3 times 10 power 8 meter per second. And besides that, the refractive index you get from the gradients of the graph may also help you to find out what is the critical angle of the glass block. And here, you must remember that the n you get must be greater than 1. If your reading of n less than 1, that means that the equation you use already reversed. So that make sure the refractive index you get must be greater than 1. Next will be type of the question. As per discussion in my previous video, there are two types of questions you are going to face. Firstly will be Tugasan Amali berpandu, where the procedure and the diagram of the experiment is provided, while for the non-guided practical assignment, or known as the Tugasan Amali tidak berpandu, the procedure and the diagram of the experiment is not provided. In the question I'm going to discuss today, the question will be in the type of the Tugasan Amali berpandu. So that means that the question I designed today is providing the procedure and diagram for the experiment. Next, you need to identify the type of the experiment. Basically, there are two types of the experiment. Hypothesis experiment involve at least 5 manipulated and responding variable. And the question will ask you to plotting the graph based on the manipulated and responding variable you get. And another type will be non-hypothesis experiment. Mostly there is not involve any manipulated and responding variable, and no any graph will be plot according to the question. So in today's question, I'm going to discuss will be hypothesis experiment. Now let's see together the candidate checklist for this question. So let's read together the instruction first. You are not allowed to work with apparatus in the first 5 minutes. The period is used to check the apparatus list, read the question, and plan the experiment which is carried out. Mark in the box provided to check the material. So that means you are providing 5 minutes to check the apparatus and material provided. For example, here we have red box with single slit, semicircular glass block, power supply, protractor and ruler, and together with white paper with quantity of 1 for each apparatus or material here. So let's say your apparatus is enough and in functioning well, you may take your checklist and immediately you go to read the question and plan your experiment. Now let us go through the question together. You are required to carry out the experiment to investigate the relationship between the angle of incidence, I, and angle of refraction, R, when light travel from air into the glass block. So here, how we know there is a hypothesis or non-hypothesis experiment? As I mentioned just now, if the question involving manipulated variable or responding variable, the question will be hypothesis experiment, and you'll be going to measure MR, and you are going to measure the responding variable based on the manipulated variable. So here you can see there is angle of incidence, which is a manipulated variable for the experiment, and responding variable here will be angle refraction. So that this is a hypothesis experiment. So we expected you need to find manipulated variable and find responding variable for plotting the graph. So you have to find manipulated variable and responding variable. Then next, the question here, the procedure is provided. First, the apparatus is set up as shown in figure. It will be like this. There is a red box, semi-circular block, white paper. So number 2, the semicircular glass block is placed on the white paper with appropriate angle skew should be drawn. So you can look at the figure. The white paper is provided, but the angle skew is not provided or not drawn readily to you to conducting the experiment. So that means you need to draw the proper angle skew for the measurement of I and also the R. Number 3, a single ray from a red box is incidence at the center of semicircular glass block from its flat edge. At the angle of incidence, I equal to 20. So from here, your incident ray must be directed to the flat edge of the semicircular glass block, not the curve. The angle of the refraction R is measured and recorded. So that means when your incident ray pass through the glass block, then you have to measure your R. So as mentioned just now, when the light ray travel from less than median, which is A here, to denser median, which is glass block here. So the speed will be decreases, so that the I you measure with R, so the I must be greater than R. Then last, repeat the step 3 and 4 with the angle of incidence I equal to 30, 40, 50, and 60. So each angle of the refraction R is measured and recorded. So as I mentioned just now, if the procedure is provided, So this will be Tugasan Amali berpandu. So that means this will be more easier for you to plan your experiment because the procedure is provided and the figure also provided already. You just need to follow the procedure. And the most important part here is you need to know how to draw a correct angle scale for your measurement. This part I will be show you in my stimulation. You may referring this procedure in my stimulation later on. And secondly, you can see this is the first manipulated variable given by the question. So as I mentioned just now, you must follow the procedure. So that means you cannot use other reading besides the reading given by the question. And your first responding variable will be measured, which is the refracted angle here. And then 30, 40, 50, and 60 will be your another MV, and each angle of refraction you have to measure. So will be your RV. So total you will get 5 MV and RV. Basically, you need to prepare. You need to draft a table like this, I and R. So 20, 30, 40, 50, and 60 before you answering your question. Okay. Next will be discussion regarding the sensitivity of protector. So most of the students have doubt regarding how many decimal places you need to put in your reading. So this one is based on the sensitivity of the protector. So from here, you can see the smallest division here to here. Oh, here to here also now. So you can see the smallest division here is actually 1 degree. So that means your reading of the angle should not be involve any decimal place. So for example, here is the case 1. So you can see the reading here is passed through this line. So what is the reading here? So we measure from 0 degree. So that means we read the inner scale here. Okay, so from here we get this will be the 30, 35, here will be 36. So the answer here will be 36. And next will be case 2. From here you can see the reading is between the smallest division here. So what is the reading we need to get? So it is between 20, less than 20. So it is between 17 and 18. So from here, you are actually allowed to give 1 decimal place, which is 17.5. So you are not allowed to give 17.1 or 17.8 or others. So because we accept the reading at middle as half of the 1 degree, which is equal to 0.5 degree. Or actually you can choose, as I mentioned, the reading is between 17 and 18. So you may just round off to 17 degree or 18 degree for this reading. Before we going to discuss our question today, let us watch together the stimulation of the experiment 6.1. The aim of the experiment is to study the relationship between the angle of incidence and angle of refraction. Second is to determine the refractive index of the glass block.
Hi students, I am Mr. Pei. In today's video, I would like to share with you how to study the relationship between the angle incidence and the angle of refractions. Besides, I am also going to determine the refractive index of the semi-circle glass block. As usual, before our experiment, we need to check whether the apparatus we get is same as the candidate checklist. Your apparatus must be including power supply, red box together with single slit, semi-circle glass block, protector, ruler, and a piece of white paper. You may check your apparatus, is it functioning well? If your apparatus is not in functioning, you may raise out your hand and ask the new apparatus from the lab assistant or your teachers. And now we may start our experiment.
Before you measure the angle of refraction with the given incident angle, you need to mark an appropriate angle scale on the white paper. Now, let me show you how to draw the correct angle scale on the white paper.
Firstly, place your semicircle block on the paper and draw a straight line at the flat edge of the semicircle glass block. As your first reference line, and then draw a normal line which is perpendicular to this reference line. So you may place your protractor, and then here will be 90 degree. Okay, and then at the bottom you also place your protractor at the line of the reference line, and again mark 90 degree at your second reference mark. Then join these two dots to become your normal line, and mark the normal line as 0 degree. Then next, using this normal line, you may measure your first incident angle, which is equal to 20 degree. Okay, so you may mark your first incident angle reading, which is 20 degree, and this dot will be joining at the intersection point of these two lines. So you can label as 20 degree. Then next, your second reading of incident angle will be 30. Again, place your protractor and measure 0 to 30 as your second incident angle. Then third reading will be 40, 50, and last reading will be 60. And again, join all the dots to the intersection point. This will be your second incident angle, which is 30, and this will be 40. This point will be 50, and the last will be 60. Okay, make sure you measure your angle from your normal line, which is labeled as 0 here. After label this, you may start your experiment. Turn on your power supply, and the wire of the red box is connected to the power supply. The single slit must be at the bottom and put in front of the red box. So a single light beam will be produced. First, place your glass block on the white paper, and the flat edge is on the line of AB here. So now you can start your first incident angle, which is equal to 20. So we expected the angle of refracted will be smaller than angle of incident, as the light traveling from the A, which is the less than median, to the denser median. So the light speed will be decreased from less than median to denser median, which is N to glass block here. directed your light ray to the flat edge of the glass block, and now you may mark your first refracted angle, and make sure the light is straight to the intersection point of reference line and the normal line, which is here. So you may mark your first refracted angle. Okay, here we can mark the edge of the glass block, so that when we remove our glass block, then we can place at the same position when we after we remove from the paper. Okay, so here will be our first angle. And we measure refractor. So make sure you measure from normal line, which is 0 here. So our reading here is about 13. Then we continue our second reading. Place at the point we have already marked. Okay, so now we can measure our second reading, where the incident angle is equal to 30. Again, we expected our second reading is also less than the incident angle, which is 30. So just now it's 13. Okay, now make sure the incident ray is point at the intersection point of the reference line and the normal. Or here we mark as O here lah. Okay. So the light will be here. Refracted light will be here. So we measure our second reading, second refracted angle with refractor again. So here, which is about 20. So which is less than 30 for our second incident angle. So we continue, place again at the point we mark, and now measure our third incident angle, which is equal to 40. So we get our reading is about 22, 25, 27. So our reading will be 27 for our third refracted angle. Again, we place our glass block and at the position we marked just now. Okay, we start to measure our fourth reading, where the I is equal to 50. Again, make sure measure from normal line, which is 0. So now my reading is 30, 32. And we continue to our last reading. Place at the position we marked early and measure our last incident angle, where the I is equal to where the I here now is equal to 60.
measure your fifth refracted angle here with your projector. Okay, so the angle here is about 41. So after this, you may tabulate your incident angle and your refracted angle in your table. So that's all for my sharing. Thank you. After watching the simulation, you all must already very clear how to conduct the experiment 6.1. And now let us go through the question together. Total mark of the question will be 15 marks. This is a question A. Tabulate your data for I, R, sin I, and sin R in the space below. So basically, the table will be like this. This is the reading of manipulated variable, which is given by the question. And as you already watched the stimulation, and you will get your 5 responding variable, which is the refracted angle. For tabulation, there is 4 important tips you need to fulfill to get the 4 full marks here. Firstly, you need to give the symbol or parameter. For example, here will be I, represented as incident angle, R, refracted angle, and the question asks you to calculate what is the value for sin I and sin R. Second, you need to give correct unit. So normally, the unit is together with the parameter. For example, length will be together with cm, for example. But here, the degree is able to write like this. So the second tips here will be you need to give a correct unit. And the sin I and sin R is not involved any unit. So third, for this experiment, you must give the correct responding variable. What is the correct responding variable? As I mentioned just now, due to the light traveling from less than medium to denser medium, which is from the air to glass block, so the speed of the light will be decreases. So the reading of the refracted angle here will be always smaller than the incident angle. And then the next will be calculate the sin I, which is using your calculator. So you get the value sin 20, so you will get this value. And normally the value for sin will be in 4 decimal places. So we just follow. So this will be the others reading. So you press sin 30, you get 0.5000. So here you must give consistent decimal point. So what means by consistent decimal point? So you can see all the reading in sin I here is with the same decimal places, which is 4. So for example here, if you press your calculator sin 30, you actually get 0.5. So to give the consistent decimal place or decimal point here, so you must give also 4 decimal places here. So we will give your reading at 0.5, 0.50, 0.500. So the decimal places here will be considered as not consistent, and the mark will be deducted. And then the next will be sin R. So for this reading, you just press calculator sin 13, so you will get this value. So again, you press all the value and make sure the reading for all sin R must be have the consistent of the decimal point here, which is 4 also here. And the value for I and R also the same, must be have the consistent decimal point. So if I say here no any decimal point, so all must be the same. So if you fulfill these 4 tips here, so you will get a full mark for this tabulation question here. Then for question B, you will request to plot the graph. And here, you have to plot the graph where sin I will be against sin R. So how you get the full mark here? So here you need to fulfill 6 tips here. So firstly, as I mentioned, we need to draw sin I against sin R. So your y-axis will be sin I, and your x-axis will be side out. So the first steps here will be you need to give the symbol for both axes S and Y. And then the next will be unit, but side I and side out here do not have any unit. So we no need to give any unit here. And the next will be you need to give the correct scale, which is involve the minimum value and maximum value. And from here, you can see this is a reading side I and side out here. And the first reading here, which is involve 4 decimal places. And you can actually round up to 2 decimal places. So 0.3420 will be 0.34. 0.2250 will be 0.23 because the smallest division for the graph will be 0.1 divided by 10, which is 0.01. So the plot is unable to plot accurate until more than 3 decimal places here. Okay, so you can round off. So second, you must make sure that your graph start with 0. And the scale must be 1 unit equal to 1. 1 multiple, 2 multiple, 5 multiple, or 10 multiple. So here 0.1 considered as the 1 multiple. So you are not allowed to give 3 multiple, 4 multiple, 6 multiple scale per unit here. So here, as I mentioned, the scale we give must include the minimum and maximum value here. So the example here, the side I minimum is 0.34, maximum is 0.87, so which is at our y-axis here. So our reading must be more than 0.87, so here is 0.9. And we start our value with 0, so definitely include the 0.34 here already. So that means the tips 3 is already fulfilled with the scale I stated here. Then 4th tips here will be you need to make sure that the graph you draw must be greater than 4 times 5 unit. So the 4 unit here will be here, and the 5 unit will be here. 1, 2, 3, 4, 5. So here 1, 2, 3, 4. So that means you need to draw the size of the graph must at least half of the graph paper. So the next will be you need to plot all the point correctly. So here, as I mentioned, we need to know the smallest division for each axis. So for y will be 0.1 divide 10. So the smallest one will be 0.01. And for the x-axis is also the same, 0.1 divided by 10. So that means the one smaller box here will be represented as 0.01. So the first reading here is 0.23 and 0.34. So 0.23 will be here. And 0.34 will be here. So it will be here. And then the second point, you need to round also. Here will be 0.50. The sign R will be 0.34. So 0.34 will be almost here with 0.5. So it will be here. So the others point will be also using the same method. You round off and plot at the correct position. Then the last tips here will be you need to draw the baseline. So what is the baseline here? So you can see the line I draw here, the above the line we have the point, and the point under the line is also, we can see is at here. So that means the baseline involves the point which is above and also under the line. And the distance of the point to the line must be equal, must be the same distance. So for example here is at this distance. So for this point, the distance will be also the same. So we not accept all the point is on the line or all the point is under the line. So the baseline, that means there is a point above the line and also under the line. So if you fulfill this all 6 tips here, so you'll get full 3 mark here. So the next question C, 1 mark. Based on the graph in B, state the relationship between the sine I and sine R. So the graph we plot just now will be almost like this. So you can see the straight line is passed through the origin. So that means the sine I is directly proportional to the sine R. So you just write the answer like this. Sine I is directly proportional to sine R. So you will get your full 1 mark here. Next, question D. Use your graph in B. Determine the refractive index N for the glass block. Show on the graph how you determine N. So how you determine N? So as I mentioned just now, the refractive index with formula sine I over sine R is actually the gradients of the graph. So that means in this question, we need to determine the refractive index. We need to calculate the gradients of the graph. So the graph is like this. So the question asks you to show on your graph how to determine N. So you need to draw a big enough triangle. Normally, it is also must be half size of the graph also. So the line I draw will be like this. So here will be a triangle. You can see. So this will be 1 mark. And I get this point is this value and the origin is this value. So we substitute in the equation we learned, m equal to y1 minus y2 over s1 minus s2. So it will be like this 0.83 minus 0, 0.60 minus 0. So we get our refractive index will be 1.38 here. I just checked the actual value for the glass block. Normally they will have the value about 1.5. So if let's say the 10% difference is a lot, so the range accepted will be between 1.35 to 1.65. So the 1.38 is between the range. However, is the value for comparison is actually based on your physics teacher who conducting the experiment together with you at the actual paper 3 exam. So that means we're not referring to the actual end of the glass block. Your answer will be reference to your physics teacher who is conducting the experiment together with you at the actual paper 3 exam. So E, based on your answer in D, calculate the speed of the light in the glass block in standard form. 2 marks here. As per mentioned just now, the relationship between the speed of the light together with refractive index will be using this formula, where the N equal to speed of the light in vacuum or air divided by the speed of the light in the glass block. So now the question asks us to find out what is the value for the speed of the light in the glass block. So here we also already learned and know that the speed of the light in vacuum or air will be equal to 3 times 10 power 8, because the light is considered as the electromagnetic wave. So the speed of the light will be this value. And just now I also mentioned to you all, the speed of the light in the glass block will be lower than the speed of the light in air. So that means the value we get here must be less than 3 times 10 power 8. So this is the basic knowledge you actually need to know before you answer this question. Now let's see together the answer. So from D, I get my value of N is equal to 1.38. So you will have your own value which is about 1.5, just now I mentioned already. And substitute your answer in D to N here. And the speed of the vacuum will be 3 times 10 power 8. So will be like this. You rearrange and you get your value of the speed of light in your glass block will be almost like this. So the question asks you to give your answer in standard form. So give your answer in 2 decimal places also and together with correct unit. So you will get substitution 1 mark and answer with correct unit and decimal places another mark. And then the next question here will be F. Based on your answer in D, calculate the critical angle of the glass block. So this one, you also has your basic knowledge regarding the relationship between the refractive index together with the critical angle, which is n equal to 1 over sine c. So from my answer in D, where the n is equal to 1.38, so you also the same substitute the value in the formula given here. So rearrange, you get your critical angle will be equal to 46.47 degree. So correct unit and 2 decimal places here. So you will get your 1 mark here. So this question is considered quite easy lah. Then the last question here. Based on your answer in F, complete the path of the light ray which is directed through the glass block at an angle of incidence 55 degree. So here the question asks you to draw your observation if the incident angle here is equal to 55 degree. So here the incident given is 55, and from F, just now my answer, I get my C critical angle is equal to 46 degree. So here we have the 3 cases for the different incident angle, where the first one, the incident angle is less than the critical angle, so the refraction will be occur. So it'll be like this. Then the second case will be I equal to C. So the incident angle equal to C. So you can see your refracted ray will be at right angle, which is 90 degree. And the third case where the I greater than C, so you will see there will be total internal refraction occur. So here you can see the incident angle given is 55 and the critical angle we get is 46. So here we know that the total internal refraction will be occur. So because our I is greater than the C I calculate just now. So second, you need to apply law of refraction where the incident angle here 55. So the refraction angle here will be also 55. So the answer will be, this is the refracted ray, where you also need to give the angle, which is also same as the angle of incidence, which is 55. So with the answer, you will get another 1 mark. That's all for my sharing today regarding the question of paper 3 for experiment 6.1. If you think that the teaching video is useful and helpful, please subscribe my channel, share and like my video. Thank you. Bye-bye.